Hi everyone, welcome to Learn Math Today. Today we are diving into the world of matrices. Let's start by understanding the origin of the word matrix. It comes from the Latin word matrix, meaning something foundation or essential. Just as a matrix is at the core of many mathematical concepts, it helps us to organize and solve complex problems. When you have more than one matrix, we call them matrices. In terms of O-level exams, matrices are relatively a straightforward topic. There are not many variations in the questions, so it's mostly about following a systematic set of steps. The key part you have to remember is the process, like how to multiply two matrices. It's pretty straightforward. If you know the steps, you'll definitely get the results you want. Matrices are not just for exams, they actually have real-life application everywhere. They help engineers to design 3D animations in video games and movies. They can help to encrypt data for secure communications. Matrices are powerful tools that help us to solve problems more efficiently. So let's dive in and explore all the steps behind working with matrices. You will see how easy they are to learn and how useful they can be in both exams and real life. Now let's use this example to visualize how a matrix looks like. Imagine you're in a classroom and try to imagine the way the desks are arranged. Each row of desks is a line of students sitting next to each other, and every column is made up of students sitting behind one another. Now, if we want to organize the name of all the students in the class based on where they are sitting, we could use matrix to represent this arrangement. In this case, the rows are the horizontal lines of students. Each row is like a line going across the classroom from left to right, and columns are the vertical seats. These are the students sitting one behind the other, starting from the front of the classroom to the back. Each spot in this arrangement represents a student sitting in a specific seat. We call this the elements of the matrix. If you are in the second row and third seat, you'll be sitting in this position where Mavis is sitting. Now let's talk about the order of the matrix. This simply tells us how many rows and how many columns there are. If there are 3 rows and 4 seats per row, the matrix is called a 3 by 4 matrix. The first number 3 is the number of rows, and the second number 4 is the number of columns. It's kind of like describing the size of a table. 3 rows of students and 4 students in a row give us a 3 by 4 matrix. When we use a matrix, we're organizing the seating arrangement in a structured way, making it easier to know exactly where each student is sitting based on the position in the matrix. This will be similar to how we use matrices in math to organize data, numbers, or even solve problems. Let's look at another real-life example. Imagine you're running a small bookstore and you're tracking the sales of 2 kinds of books, fiction and non-fiction. You want to compare how many books you sold in the last 3 months to see trends or make some predictions. You obviously will start writing the sales down in a table form, like the one shown here. Now that you have this table, you can actually convert it to a matrix. Now, how many rows does this matrix has? And how many columns does this matrix have? This matrix has 2 rows and 3 columns, which is also known as the order or the dimension of the matrix. Every element in the matrix corresponds to an entry in the original table. For example, in the first row, second column, where the entry is 55, it means in the second month, 55 fiction books were sold. Now, why do we need matrices? Before we go on to understand and see how to perform operation on matrices, I at least want you all to have a appreciation of how matrices are useful in our everyday life. For example, just now you saw a table being used. This is like a spreadsheet, or if you use Excel in Microsoft, they're used for tracking stuff, like maybe sitting plans or keeping track of your scores in different subjects. All these rows and columns of data are organized just like a matrix. It's basically a big grid where every piece of information fits into a specific spot. Matrices are also used in technology and graphics. Have you ever played a 3D movie or video game? The characters and environment you see on the screen are all created using matrices. When a character or a camera is zoomed into a movie, matrices are actually behind the scene, helping to compute all this movement. AI also heavily use matrices. AI like virtual assistants like Siri or Alexa understand the world around them. Matrices help AI to process huge amount of data to make decisions, like recognizing a voice or spotting a traffic light. Matrices are also useful in keeping your data safe. When you do something like sending a message over the internet or logging to your bank account, matrices are the one that help to encrypt or decrypt your information so that hackers cannot steal the information. It is like having a secret code that only the right person can unlock. This is called cryptography and it's a big deal for keeping things like your personal information and password safe. A matrix is essentially a rectangular array of numbers arranged in rows and columns. You can think of it as a table of data where every value has a position based on the row and column. For example, you have a seating arrangement in the classroom. Each chair can be thought of as a cell in the matrix, with the row representing a specific rows of chairs and the column representing which position the chair is from the left. We use matrices to organize and work with data, and a matrix with m rows and m columns is called a m by n matrix. This tells us the dimension of the matrix, in other words, the order of the matrix. M refers to how many rows it has, and n tells us how many columns it has. For example, a 2 by 3 matrix has 2 rows and 3 columns. The individual numbers within a matrix are called elements, and they can be identified based on the position. For example, if looking at the element in the second row and third column, we can write that as A, subscript 2, and subscript 3, where the subscript tells us which row and column it is in. In this example, we have a matrix that has 3 rows and 2 columns. The order of the matrix or the dimension of the matrix tells us how many rows and how many columns it has. So here we say that this matrix is a 3 by 2 matrix, where the first number represents the rows and second number represents the column. Remember, it's always row first, then columns. The total number of elements in the matrix is the number of rows multiplied by the number of columns. In this case, we have 3 times 2, giving us 6 elements. So anytime you see a matrix, just have to remember to count the rows and columns to know what's the dimension and what's the order. That's pretty easy. As the name suggests, a square matrix has the same numbers of rows and columns. In other words, the number of rows and columns are equal, and it has an order of n by n, where n is the number of rows and n is also the number of columns. A row matrix has only one row but multiple columns. It has the order 1 by n, where n is the number of columns. A column matrix has only one column but multiple rows. It is of the order n by 1, where n is the number of rows. Now let's look at a 1 by 1 matrix. Is a 1 by 1 matrix a valid matrix? Yes, it is a valid matrix. A matrix is defined by a rectangular array of numbers arranged in rows and columns. There is no restriction on the number of rows and columns. In this case, there is just one row and just one column. So it looks like a single number. It is considered a matrix and follows all the rules of matrix operations like addition, subtraction, and multiplication. For example, you have this matrix, 1 by 1 matrix of 5. It behaves just like any other matrix with just one element. Is it a row matrix? A row matrix is a matrix with only one row and multiple columns. For example, we might have a row matrix with 3 columns that looks like this. Note that the number of columns has to be more than 1. Therefore, a 1 by 1 matrix is not a row matrix. Similarly, for a column matrix, the number of rows has to be more than 1. So in this case, a 1 by 1 matrix is not a column matrix. For the last question, is a 1 by 1 matrix a square matrix? Yes. By definition, a square matrix is one where the number of rows is equal to the number of columns. In a 1 by 1 matrix, both the number of rows and number of columns is 1, so it satisfies the condition of being a square matrix.